Just a little review. Let's look at one of those. What if we wanted to factor x squared plus 2x minus 35? Okay, take a second and try do as much of that as you can on your own. See if you can get it set up at least. Hopefully you can get it factored, and then we'll talk about it. Okay, so what can you tell me about this? What can you tell me about this now? It's factoring means what? Okay, breaking it apart, right? I want to break it apart into a product of two factors. So factoring is like unfoiling, right? Okay, so what is the answer going to look like when we say factor that? Okay, good. It's going to look like, we know that it's going to look like that if it factors, right? And it might not. It really might not. If it doesn't, for now we're stuck. Later on we'll have other strategies to use. Okay, so keep going. What else does our answer have to look like? What do we know before we even start thinking about it?
2x's.
Okay, the first terms of each factor are x. Very good. Okay, what can you tell me about the signs of the magic numbers?
One's positive and one's negative.
One's positive and one's negative. Good. Okay, the two numbers. Now I'm gonna kind of pick on people here a little bit. The two numbers have to multiply, Amber, to what number? Negative 35. Good. And they have to add to, okay,
Positive 2.
positive 2. And okay, Amber, you were gonna tell me what they were.
Okay, it's 7 and negative 5.
7 and negative 5, and we're done. Right?
It doesn't matter where you put those, right?
Nope. The order doesn't matter. Either way. Okay. So that's factoring easy quadratics. Now yesterday we took that a step further and we looked at factoring some harder quadratics. But today, so we're going to do two things at once here. Today kind of the topic is, if I had to say what's our learning objective, it's going to be solving quadratic equations. Factoring is going to be instrumental in doing that, but really the whole point of factoring is to solve equations, right? So, and that's the name of the assignment that'll follow this. So here's an example of one. We want to solve this quadratic equation. What if we want to solve the equation 4x squared plus 12x minus 160. Actually, what I'm going to say is, okay, let's solve that equation. 4x squared plus 12x equals negative 160. Okay? Now what are the steps that we could go through to solve this thing? What do you think, Michaela?
Maybe minus 12x from
Okay.
both sides.
Okay, maybe minus 12x from both sides. That seems reasonable. In this case, it's not what we want to do. Now I understand why you might be thinking that though, because in the past, it's been probably a week and a half since we really talked about this, or a week anyway. We've always tried to isolate a variable, and I think tell me if I'm wrong, but I think what you maybe were looking at there is to isolate that x squared, we got to get it by itself. Okay, there's a problem with that though. This time, I can't point to a single variable, so I can't isolate it. Gabby, do you have an idea? Yeah, well, it turns out we could divide by 4. You're right. I'm gonna hold off on that, but you're right. Yeah. Any other suggestions?
Can we combine them?
We can't. There's nothing that combines there. None of those are like terms, are they?
Don't you like square them?
No, not quite, not quite. You were getting a little bit off track on this. Now, and I get it, because we haven't really done this yet. We've talked about it, but we haven't done it. So here's our goal. When we can't isolate a variable, which we cannot do here, we have to go back to our trick of setting it equal to 0, the equation equal to 0, and factoring it. So really what we want to do here is we want to put this into what's called standard form. We want to get it set equal to 0, okay? So I'm going to add 160 to both sides. Seems a little strange. If I do that, if I get 4x squared plus 12x, what I really wanted there was, I wanted that to be a plus 160. So I'm going to subtract 160 from both sides. Okay? All right, now why did we do that? Well, it's important. This is actually really important to do. That's called standard form, when it's set equal to 0. So this equation is a quadratic equation in standard form. Ax squared plus bx plus c equals 0. And the reason we want to do that is because our goal here, if possible, is going to be to break this thing up into a product of factors. Set equal to 0. Remember that little trick I played on you last week where I asked you to multiply a whole string of numbers together and it seemed impossible? But everybody got the answer because eventually I multiplied by 0, which made the answer 0, right? The moral of the story being that when you multiply by 0, you have to get 0 for an answer. In fact, the only way you can multiply numbers and get 0 for an answer is when you multiply by 0. There's no other way, right? And so if we can break this thing down into factors, a product of factors, I know that the only way the product of those factors can equal 0 is when each individual factor is 0, right? And so what I'm left with then are some simple, small equations to solve instead of this big, ugly quadratic one, right? So let's do that process. All right, so first of all, can we factor this? We're looking at the left side. We want to try to break the left side apart as far as we can. When we factor, that means we're going to break it apart into unbreakably small pieces, okay? We always want to see, is there a common factor that I can factor out first? And that's kind of what we talked about yesterday. Gabby found it. What's a number that goes into all three of those? 4. So I could factor out a 4. If I factor out a 4, undistribute a 4, what's left over? First term is going to leave me with x squared, good. Second term is going to leave me with 3, good, because 4 times what is 12? So 3, and I need an x, right? And then the last term, negative 40, good. Okay, and then I've got all that stuff equals 0, right? Okay, so now the question, now this gets easier. Now that we factored out that 4, look what we're left with. We're left with an easy quadratic to factor. If it factors, it's easy because I have a 1 in front of the x squared, right? So you already told me how to do that. I know that this part right here is going to break apart, if it factors, into something like that. I'm going to get an x there and an x there. Can you find two magic numbers that multiply to negative 40 and add to 3, Jerry? Negative 5 and positive 8, exactly. And then we actually have that 4 out front also. Okay, okay, so now, thank you. So now, oh, she's focused on. Yeah. Did I get, I'm gonna make sure I get everybody down there. I'll take just a second. I think I did, but. Okay, so now we got this thing broken apart, right? So now we're going to use our trick, the 0 product property. So the zero product property says that the product of those three factors can only be 0 when individual factors are 0. Well, 4 cannot be 0, right? 4 is constant. That's not 0, so we don't worry about that one. But these other two could be 0, right? X minus 5, the factor x minus 5 is equal to 0 when x equals what?
5.
5. So I'm just going to solve that equation. Very simple, right? So I get either x equals 5 or the factor x plus 8 equals 0 when x is negative 8. So those are my two solutions.
Wait, why don't you touch 4?
Because 4 can't equal 0. 4 is just a number, right? Only the factors with variables we could actually solve. Because x can vary. X could be anything, right?
Yeah.
So when x has the value of 5, this factor right here is equal to 0, right? When x has a factor of negative, or when x has a value of negative 8, that factor is equal to 0. But 4 can never equal 0. Only the factors with variables count. And in fact, Gabby had a good suggestion. She just said, why not just divide both sides by 4 to get rid of that? I can. It's fine. When I'm solving an equation, if I divide both sides by 4, what's 0 divided by 4?
0.
It's just still just 0, isn't it? Right? So I could even just get rid of that 4. Okay? Does that make sense? So how can I check my answer? Plug it into the original equation, right? I could plug in positive 5 or negative 8 and see if my original equation works, or that one works, right? Notice one other thing here. This is the most common mistake people make is they find the magic numbers to be negative 5 and 8. Are those the answers? No, they're not. The answers are the zeros of the factors, not the magic numbers. Okay? Questions on that? Okay, let's try another one. All right, so I'm going to give you a slightly different, I'm going to phrase this a little differently, but it means essentially the same thing. What if you get a question, and you will get some like this, that say, find the zeros of f of x equals...
And borrow one from the book here, how about?
Okay. What does that mean? Find the zeros of. Now, what are zeros of a function?
The opposites.
Well, I mean, kind of. Let's just graph one and see. It's easier to see if we think of it in terms of a picture. So if this is my function, something like that, let's say. Yes, ma'am.
Where it crosses it.
Exactly. They are where it crosses the x-axis. The zeros of a function are going to be these places right there, and right there. Those are the places where y has a value of 0. If I look at the coordinates of all three of those places, in each case, the y coordinate is going to be 0, right? Does that make sense? What I'm looking for are the x values. Those are the zeros, okay? So zeros and x-intercepts mean the very same thing. Okay, so it's where y equals 0. So if I go back to my problem then, finding the zeros of a function, what am I going to do? I'm going to set the whole thing equal to 0 because I want to know when is the function f of x, and f of x is just a fancy name for y, right? I want to know when does y equal 0. Does that make sense? So then I'm just going to turn this into the equation. Whoops. I'm going to turn this into the equation 8x squared minus 6x minus 5 equals 0. okay?
Oh,
And it becomes just like the last one we did, right? Okay, only this one is a little bit harder. Why is this one harder? Because why? There is no greatest common factor. Yes, exactly. That makes it tougher, right? Now this is that process we went through yesterday, okay? So if I want to factor a quadratic where a is not equal to 1, but I can't factor out a greatest common factor, I am stuck. Now what do we call this process? What's our a times c, then split b. A times c, then split b. Everybody say that. Okay, a times c, then split b. I don't know. It's kind of weird. I'm making you say it, but it really helps. So what's a, b, and c in this case? A is 8. B is -6. Good. C is. So what's AC? -40. So I want to find two magic numbers that multiply to -40 and add to -6, that add to B. Multiply to AC and add to B, right? What would those be? Multiply to -40 and add to -6. What do you think? Positive 4, -10, right? Does that make sense? So we can split that -40 up into a -10 and a positive 4, right? Okay? So what did we do with that? Here was the part that was a little strange, right? What we did with that was we used it to factor the trinomial. We wrote the trinomial instead of a trinomial with 3 terms. We split the b term up and we broke it into 2 separate groups. Okay, what were the contents then in this case of the first group? Okay, good. So we're going to split the -6x. The -6 is going to split up into a -10x plus a positive 4x, right? That's the whole point of this, was to say -6x equals -10x plus 4x. That's how we split it up. So it doesn't matter which order. We'll go ahead and put the -1 first. I like to, if there's a negative and a positive, I always like to put the -1 first, but it doesn't really matter. And so then we're left with over here a positive 4x minus 5, right? Okay, are you okay with that? Right, now we know we're always going to get this pattern. And remember, here's the cool thing about this. If we can find magic numbers, it will factor. If we can't find magic numbers, it won't factor. So you know right away whether or not you can find those numbers tells you whether you have to go any further. Okay? We found them though. So if we find them, remember then that we're going to follow this pattern. Each of the groups is going to break up into a greatest common factor and a leftover, right? So let's focus on the first group. What's the greatest common factor of 8x squared and 10x? What's the number part? 2. Okay, the variable part? X. Good. Okay, so what's left over? 2 times what is 8? 4. X times what is x squared? X. 2 times what is -10? And then x times what is x? Well, 1, right? So that's it, right? That's our leftover. Now, what was the trick? Question, yeah.
Yeah, I'm confused.
Okay,
The
so
second part,
with this part right here?
up top.
Right.
Yeah.
Right here?
Yeah.
Okay, we haven't even done that yet.
Well, I know, I'm confused on how you even got that.
How I got this stuff over here?
No, the four X and minus five.
Oh, this, okay, the whole black equation, I got you, okay.
Yeah.
Because that's what the magic numbers did for us, right? We said that we found our magic numbers were
-10 and 4.
-10 and 4. So that means that this -6x, the -6, is splitting up into a -10 and a +4.
Okay,
Now, both of those have to have an x attached because the negative 6 is actually multiplied by x.
Okay, and then you just brought down the negative 5?
Right, right. Because all we've done is we've taken these three terms and we've just split apart the middle one so we have 4 now instead of 3.
Okay.
Okay? Does that make sense?
Yeah.
Okay.
I didn't know that you put the 4x there.
Okay, Ashley, is that making sense?
Yeah.
Okay. Okay, so then everybody sees how we get the first group factored. Right now, here's the other really important part of this pattern. Once we get a leftover from the first group, what does that tell us about the second group? Exactly, it has to be the same thing, so I can immediately just go write the same leftover in the right group, and then all I have to do is answer the question, what number would I distribute to the 4x minus 5 to get group 2? In this case, it's just a 1, isn't it? Okay. Now, that's almost the trickiest one, though, because sometimes people just don't even write the 1 there. You know, they think of it as a 0, but it's not. It really is a 1. What times 4x minus 5 is 4x minus 5? 1, right? Okay. Say it again.
I just don't remember how to get.
Okay, so how to get the answer, right? So now, how do we get the answer out of this?
Wait, how'd you get the 2x again? At the beginning?
Because we look for the greatest common factor from the first group.
Oh,
Okay? Make sense? Okay, now remember here, the whole time though, we're solving an equation. So we haven't gotten to this part yet. But our goal is we want to now take that whole left side and write it as a product of two factors. We're not there yet because look, we've still got a plus sign. We've still got some stuff plus some stuff. But we're one step away. Here's the step. So now if we look at the group 1 and group 2, wouldn't you agree that each group has a red factor times a blue factor?
Yes.
The blue factor is common though. So it goes first. So I can undistribute the blue factor, right? I can undistribute it from each of those two groups. If I undistribute it, so now it's sitting out front, all we have to answer then is what's left over from each of the groups. Well, from the first group, what's left over?
2.
Yeah, when I pull this away, I'm left with a 2x. From the second group, I'm left with plus 1. Right? It's factored. Okay, so now all we have to do is our zero product property trick. Right? So we're gonna ask ourselves the question, what are the x values that make each of those factors turn into 0? So we just solve some small, simple equations. Right? We're gonna set the first factor equal to 0 and solve. So one solution would be when 4x minus 5 is equal to 0. Well, what are the two steps to get the x by itself? Add 5 and divide by 4. So that isn't x just 5/4, right? So there's one 0. And then here's the other one. We could set the other factor, 2x plus 1, equal to 0, and solve to find what's the value of x that makes that happen. What's that going to be? Negative 1/2. Right? If I subtract 1 and divide by 2. That's it. Those are my solutions. Okay? See how that works? So you can put that away. Make sense?
Yeah.
Okay, it's a process, isn't it? I mean, it really is kind of a process. Yeah, it could be worse. Could be worse. Okay, try another one. I'm gonna give you another one to try here. How about? Yes. Yes, you may. Okay, solve that, please. Okay, you got an answer? Okay, a question? All right, let me just finish. All right, excellent. Okay, this one looks a little different, but this is an easy one, right? Is there a greatest common factor?
Yes.
Yes, there is. What is the greatest common factor here? 4x. Yeah, that's great. Whenever you can factor an x out, that makes the problems really simple. Okay, we'll see what. So I can undistribute here a 4x. What is left behind if we do that?
10x.
10x plus, not nothing. Nothing would be 0. 1. Yeah, because we're asking the question now, when I undistribute this, 4x times what is 4x? 1, right? Can't forget that 1. And you should always, when you're done factoring out a greatest common factor, just glance at that and say, okay, now if I distribute the 4x, do I get back what I started with? Yeah, we do, right? Okay, so now, why is this so easy? I've got this thing factored. Now I should be able to apply the zero product property, right? Okay, so what are the two equations I'm going to set equal to 0? Right. Okay, so over here I've got the equation 4x equals 0. That's a really easy one. 0, isn't it? Yeah. If I divide both sides by 4, 0 divided by 4 is just 0, right? Okay, now, anytime, this is always going to work that way, isn't it? Anytime I just get a greatest common factor with a variable in it, when I set that equal to 0, I'm always just going to get 0 for my solution, aren't I? Right, so those are easy. Now, the other one's not too bad either. What am I going to get for that one if I set it equal to 0? Negative 1 over 10. Does everybody see that? I'm going to subtract 1 to the other side and divide by 10. That's it, right? Okay, good. Good, good.
Is that what we're doing?
This, if you can get this is good. I mean, this is the hardest part of the chapter. If you can get this, the rest of the chapter is going to be, it just gets easier than this. I'm not going to say it's just dead simple, but it's easier than this. Okay, let me give you one more. This is good practice.
Yeah. We had an idea.
Oh, yeah.
Solve that. Actually, hang on. Let's do. Solve that. So what's the first thing we want to do with an equation like this? Okay, almost, well, we're going to get there. But first thing,
Oh.
good. Put it in standard form. Get everything on one side, set it equal to 0. Perfect. So that means, oh, and by the way, here's something else I need to say about that. It's not as big a deal right now, but when we get further in the chapter, this is going to be huge. You always want to make sure that the coefficient of x squared, so a, is positive, right? So we want to push everything to the side where the first term is positive. So that's going to be the left side here, isn't it? So 15x squared, what? Minus 39x plus 18 equals 0. Okay, now here's something else we can do to kind of make our lives a little bit easier. Because this is an equation, right, we're trying to get this broken apart into variable factors. You could always just say, is there a greatest common factor here?
No.
Yes, 3.
How'd you know 3? Okay, how'd you know it goes into all 3 of those?
Divided by 2.
Okay, yeah, if you add up, everyone knows that trick, right? If you add up the digits, if the answer is divisible by 3, then the number is divisible by 3.
What?
right? So for example, 15, it's pretty obvious, but 1 plus 5 is 6. 3 goes into 6. So therefore, 3 goes into 15. Yeah, that's a good trick.
That's so cool.
Yeah, 3 plus 9 is 12. 3 goes into 12. And you can even go, I'll show you what, you can even go further than that. Watch this. We could even do, if you wanted to know, this is really cool. If you want to know if 3 goes into this number, if I want to know if 3 goes into that number, that seems like a pretty tall order, right? But it's not hard to do. If I add up those digits, what do I get? 7 and 1 is 8, and 4 is 12, and 9 is 21, and 9, I picked a bad one. Let me make that instead. I'm going to add one more digit there. Let's make that 9. Add a 9 at the end. So it adds up to 39, right? If I add all those up, the digits add up to 39. Well, what if I get a big number when I add up the digits? Do it again. 3 plus 9 adds up to 12, and that's easy enough to work with, right? You can keep repeating the process as much as you want. Interesting, huh? Okay, so
Like personal calculator right there.
yeah, how about that? So then, okay, so now I know that 3 goes into all of these, right? So I could factor out a 3. What's left over when I factor out the 3? 15 divided by 3 is, so 5x squared minus 13x plus 6. Okay, so is there, now, can I go further? Is there another greatest common factor?
No.
No, 13's prime, isn't it? Right? Okay, and while I'm at it though, what about that 3? Couldn't I just divide both sides by 3?
Yes.
Get rid of it. Don't need it, because it's an equation, right? We're solving an equation, and that's not going to change our answer, right? So now we got to do a times c, then split b. So that's your next task. Okay, so try that. And you can compare notes with your neighbor and work together, that's fine, but see if we can get through this.
Would that still be 5x squared or just 5x?
No, it'd be 5x squared, because all we took out was a 3. We didn't take out an x, right? Okay? Yes. Yes. Yes, you gotta find numbers.
8 times c
Multiply
is
30 and
30.
add to negative 13.
It's 5 times 6.
Right, 8 times c, then split b.
That equals 30, and then you have to figure out what goes into 13.
Okay, now what are the signs of those?
I don't know if I wrote it.
Multiplies to 30 and adds to negative 13. Okay, so now, but what's negative is then? 3, 6. There you go. So now I gotta factor out the greatest common factor. Right? Okay, yeah, so we gotta get greatest common factor. Root of root 1, not 2. Biggest thing that goes, what's the biggest number that goes to 5 and 10?
Wait,
5, right? Okay. Take an x out also. Okay. Alright.
positive.
Okay, now hold on, so 5x times 5 is
10 and 3. Oh. 10 and 3.
there you go.
Oh, wait.
That's real easy. That's okay. You'll get to that later. So you'll get to the first thing you do. Don't worry about that part. You're just gonna put the rest of it. Number is there. Negative 10. Right? Okay, we're getting it. This is good. Yes. Okay, but now what's up there? It's not just a -2. I have to, when I undistribute 5x, I'm gonna have to get apart from each of those vector terms, right? So it'd be x, good, x minus 2. Yep, there you go. Okay, let's have a look. Okay, what is, we put it in standard, now here's what we're trying to factor, right?
Yeah.
So this is the part we're focusing on. What is A, B, and C? A is, okay, so the A is just the 5, right? Yeah. B is
6.
and C is 6. So AC is 30. Okay, so we want to find numbers that multiply to 30 and add to -13. What would those be? So -3, -10. Good, right? They'd have to both be negative, wouldn't they? Right? Okay, so I'm going to split this up into -3 and -10, right? Okay, so now we're going to take all of this stuff and we got to break it up into 4 groups, right? I mean, excuse me, into 2 groups of 4 terms. Okay, so anybody want to come fill in the blanks? Did you want to, Jerry?
Yeah.
Okay, come on up. Very good. Does anybody want to add just I heard some people make want to make a slight adjustment. You did the hard part. One small piece, and you probably, oops, not, hang on. We just go
Oh, wait,
back.
right here.
Right there, yes. Yeah, so click that twice. There you go. Everybody agree with that? Does that make sense, Jerry?
Yep.
Okay, because we're splitting the 13 up, the -13 up, but the -13 is actually times an x. So the x gets dragged into both. Does that make sense? Okay, all right. What brave soul, I'll rewrite this so you can see it a little better. I want some brave volunteer come up here and push this process forward a little bit more. That was a 10x, right?
Yeah, negative.
Okay, who's next? Come on up. Okay, you can even put the colors in there. Just click on that to get red. I'll start you off. There's red for the greatest common factor. Yeah, for the first group, right? Okay, good. More blue. Okay. Good. Okay, so now I'm going to off to somebody else. Okay, hand it off.
How do you get the x minus 2?
Okay, tell her, how'd you get the x minus 2?
So, on the greatest common factor divided by 5.
Oh, you do 10x divided by 5.
You do 10x divided by 5x to get the 2. Does that make sense? Okay. Remember, when you factor out a greatest common factor, you're just dividing everything by that to see what's left over. Okay, next person. You're good. That's perfect. Next person.
Yeah, I know. Right?
Okay, so what do you know now? What's the next step here? What do you know right away? How is this? What do you know for sure? Ah, good. Oops, hang on, I'll do this for you. So you want right there. Now you're set. Go ahead. Good. Okay, everyone watch, please. Watch. Okay, and what goes out front? Perfect. Very nice. Okay.
Jordan,